Welcome to the world of Kubernetes, a game-changing tool revolutionizing how we deploy and manage modern cloud-native applications. At the heart of this system are pods and deployments. Pods serve as the fundamental building blocks, bundling your application containers together. Meanwhile, deployments ensure that your applications are consistently updated and scaled with ease. By utilizing these powerful features, Kubernetes enables seamless application management, optimizing uptime and resource efficiency. As we delve deeper into Kubernetes, it's essential to acknowledge the common challenges faced when deploying applications at scale. Primary issues include experiencing downtime during updates, which can interrupt services and user experiences. Moreover, resource inefficiency often leads to increased costs and underutilized infrastructure. These challenges highlight the need for a robust system that can facilitate seamless updates and dynamic scaling without incurring additional overhead. Let's explore how Kubernetes addresses these issues with its innovative solutions. Building on the challenges of traditional application deployment, Kubernetes introduces a transformative approach with pods and deployments. A pod, the smallest deployable unit in Kubernetes, encapsulates one or more containers, allowing them to share resources efficiently. This ensures consistent communication and resource distribution among application components. On the other hand, deployments manage these pods, automating updates and scaling operations, thus guaranteeing minimal or zero downtime during such transitions. This synergy between pods and deployments is crucial for optimizing application performance in cloud-native environments. Let's dive into a practical example. We'll create a Kubernetes pod using a YAML file and then deploy an application with kubectl commands. Here's the YAML configuration for our pod and deployment. Notice how the deployment specification allows you to set the number of replicas. After applying this configuration with kubectl apply, the deployment will manage your application scaling automatically. You can easily scale the deployment using kubectl scale, adjusting the replica count as needed to handle increased traffic or load. This demonstration shows Kubernetes' powerful capabilities to manage application scalability and reliability in real time. Following our demo, let's delve into best practices for using Kubernetes pods and deployments effectively. Start by organizing your pods with labels. Labels facilitate grouping and selecting pods, crucial for management and scaling tasks. Employ readiness probes to ensure applications are fully functional before routing traffic to them, enhancing reliability during updates. However, be cautious of common pitfalls. Neglecting resource limits can lead to resource hogging and service disruptions. Also, ensure you have a robust rollback strategy to quickly recover from failed updates. Avoid these pitfalls to maximize your Kubernetes efficiency and reliability. In summary, mastering Kubernetes pods and deployments is crucial for streamlining application management, ensuring efficient resource utilization, and maintaining zero downtime during updates. These tools enable you to manage complex applications with ease and agility. Remember, consistent practice and application of best practices will enhance your Kubernetes proficiency. We'd love to hear about your experiences or questions. Share your insights in the comments below and join the conversation. Don't forget to like and subscribe for more deep dives into cutting-edge tech.